This is the video for 6.5 and we are talking about linear inequalities. A linear inequality is an inequality which involves a linear function. So for example, y is less than or equal to x plus 2 is a linear inequality. A solution of an inequality is a number which, when substituted for the variable, makes the inequality a true statement. Example number 1, is the ordered pair 1, 2 a solution of this inequality? So how do we determine if this ordered pair is a solution of this inequality? Well, remember, an ordered pair is an xy coordinate. So all we need to do is substitute the xy coordinate 1, 2 into the inequality and determine, is the inequality a true statement? So when y is 2 and x is 1, is this inequality a true statement? And yes, it is, because 2 is greater than -2. The ordered pair 1, 2 is a solution of this inequality. So let's look at the next example. Is the ordered pair -3, -7 a solution of this inequality? Well, again, remember, this is an ordered pair, so all we need to do is substitute the values for the variables into the inequality and determine, is the inequality a true statement? And here, no, it is not. -7 is not greater than -6, so no, the ordered pair -3, -7 is not a solution of this inequality. So go ahead and hit pause and work out this on your own example. The answer is yes. 3, 6 is a solution of this inequality because 6 is less than or equal to 6. Remember, this line here means or equal to. Now we're going to talk about how to graph an inequality. Now you should have done this last year in pre-algebra, so this should be review. But let's review. What is the difference between a dotted line and a solid line? So remember, if it's less than or greater than, you are going to have a dotted line because that means the solutions of the inequality do not lie on the line itself. However, if you have a less than or equal to or a greater than or equal to, you will have a solid line because that means the solutions of the inequality will lie on the line itself. So pause the video and write that down because that's super important for you to remember. So now let's go over how to graph this inequality. Remember, this is the same thing as saying y is greater than mx plus b. So what's the y-intercept? The y-intercept is at -2, and my slope is 1 over 1, and it's a positive slope. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And the line is going to be dotted. I'm also going to go down 1 over 1, down 1 over 1, and again, the line is dotted. Okay, so there's the line. It has a y-intercept of -2. It has a slope of a positive 1 over 1, and the line's going to be dotted. Now I have to highlight. Because this is greater than, I want to highlight up towards those positive y values. Remember, you are always highlighting in relation to those y values. So when it's a greater than, you want to highlight up towards those positive y values. If it's a less than, you want to highlight down towards those negative y values. Again, pause the video and write that down. That's super important to remember. When you're highlighting, when it's a greater than, you're highlighting up towards those positive y values, and when it's a less than, you're highlighting down towards the negative y values. So let's review, what exactly does this graph mean? It means all of the possible solutions of this inequality, or all of the solutions of this inequality, lie in this shaded region here, but not on the line itself. So you can grab a test point to make sure that you shaded correctly. So for example, the origin 0, 0 does lie in the shaded region. So it will be a solution of this inequality. So how do I check that? Again, just to make sure that I highlighted in the right direction. Well, take the coordinate point 0, 0 and plug it into the inequality and make sure that it makes the inequality a true statement. Go ahead and hit pause and work out this on your own problem. Graph this inequality. Here's the answer. My y-intercept is at positive 1 and my slope is a positive 1 over 2. So what did I do? From this point of positive 1, I went up 1 over 2, up 1 over 2. And then I also went down 1 over 2, down 1 over 2. My line is going to be solid because it's an or equal to, and then it's a less than, so I highlighted down towards those negative y values. So what exactly does this mean? All of the solutions for this inequality, all of the coordinate points that are going to make this inequality a true statement lie in this shaded region here and on the line itself. Again, all of the possible solutions, all of the coordinate points that make this inequality a true statement lie in this shaded area here and on the line itself because it's a solid line, because it's an or equal to. So it's super important that you understand what the graph means. You need to be able to graph it, but you also need to understand what it means. Example number 3, x is greater than negative 1. So how am I going to graph x is greater than negative 1? And what exactly does this mean? All values of x that are greater than negative 1, but not including negative 1. So the line is dotted. And remember, this goes on towards infinity. There are an infinite number of coordinate points that will make this inequality a true statement. Y is greater than or equal to 2. What exactly does this mean? All values of y that are greater than 2 and including 2. So it's going to be a solid line because it's an or equal to. So pause the video and work out these two practice problems. Here are the answers. All values of x that are less than -5, but not including -5. So the line is going to be dotted. All values of y that are less than 2 and including 2. So my line is going to be solid because it's a less than or equal to. All values of y that are less than or equal to 2. And finally, example number 4, writing an inequality from a graph. So you are going to set it up in the same way you set up a linear equality, except it's not going to be y equals mx plus b. Here you're going to have an inequality symbol. So let's start by doing exactly what you do when you have a linear equality. Where do you start? Well, the first thing you need to do is you need to identify what's the b, what's the y-intercept. And here the y-intercept, or the b, is +1. So you know this is going to be +1. Okay, well, what's the next thing you need to do? You need to identify the slope, or the m. Your slope is going to be negative. And what am I doing in order to go from one point to the next? Here I'm going down 2 and then over to the right 2. So my slope is -2/2, or I can say -1. So my slope, or my m, is going to be -1. Well, now I have to identify the inequality symbol. So I have to ask myself, is this graph highlighted up towards those positive y values, or is it highlighted down towards those negative y values? So here it's highlighted down towards those negative y values, so you know this is going to be a less than. And then finally, you need to ask yourself, is the line dotted or solid? Here the line is dotted, so that means the solutions of the inequality do not lie on the line itself. So it's just going to remain a less than. It's not going to be an or equal to. So the inequality that describes this graph is y is less than -x plus 1. And you can grab some test points to make sure that this is correct. So for example, the origin, 0, 0. Here the origin is inside the shaded region, so plug the coordinate point 0, 0 into the inequality and make sure that it makes the inequality a true statement. Okay, so go ahead and hit pause and create an inequality that describes this graph. Here's the answer. Y is greater than or equal to -3x plus 4. My y-intercept is at +4. I have a negative slope. And how do I go from one point to the next? Here I'm going down 3 and over 1. So my slope is going to be -3/1. It's highlighted up towards those positive y values, so it's going to be a greater than. Remember, this highlighted area here goes on towards infinity. So if you extend the highlighted area here, you can very clearly see how this is highlighted up towards those positive y values, so it is a greater than. And then finally, you have to ask yourself, is the line dotted or solid? Here the line is solid, so it's going to be an or equal to. So one last time to make sure that you fully understand what this means. The coordinate points that are going to make this inequality a true statement lie in this shaded region here and on the line itself because it's a solid line.